So hello, welcome to the class, industrial plant class. Okay, so opening up the. Actually, I changed my laptop, so maybe my environment has been changed a bit. So let me check. So I moved my iPlant directory here, but I think I successfully made my environment here. So I will run to Python lab. Hello, root. Oh, I didn't install. Conda install. Python. So, opening up the what? No, but I can check the site. Okay, now we are in our working product. But before we starting, actually I updated my Windows Linux subsystem WSL subsystem Linux. So I changed this to WSL2. So recently Microsoft announced the subsystem 2. So I heard that is be more faster than before. So if somebody actually interested in this WSL2, then please visit this site and maybe you have to update your window to this version. And also you have to join to the Window Insider program. So the steps bit tedious, but after you install this WSL2, I think your working environment will be more present, I think. So let me check. What have we done? So maybe no. Yeah. So Arabidopsis upstream blocks. So we are working on the Arabidopsis sequence because we have to compare the expression data rather than the what was that? So we want to compare the expression and the profile of upstream block. So what was our idea? So I made this documentation. First, we have to cluster the expression pattern. Then the expression pattern is coming from specific experimental design, right? So the cluster. So the clusters are experimental design specific. So the specific environmental condition may require different promoter composition. So certain environmental condition may express specific transcription factor set. So transcription factor require different set of promoter. So the idea was let's make clustering first. So let me open up new file Arabidopsis No. Arabidopsis expression clustering, right? So let me copy the starting point of us. Starting point. This is our starting point. Okay. So actually, I didn't install anything there. So what happened? So why this? Okay, this will be better. And I install pandas. I think I have to install Seaborn, Matplotlib, NumPy, everything. I think I feel faster than before using WSL2. Also, my environment become better than before. So I bought new laptop, so I can show you how good it is. So the memory is 32 gigabyte, and what is this CPU? I don't know. So this is really good. I heard. Okay, then let me check how many core I have. So I have the 12 cores. I didn't know that. Really good. And anyway, what am I doing? Okay, so I have to install again NumPy also. Okay, and Seaborn. So this kind of analysis is very important for you because so one guy is actually waiting the expensive non-free software for the analysis, but the software update very slowly. So if you want to catch up any genomics and any omics technology, you have to use this kind of technology. I mean technique. Yes. That is my opinion. So if you are waiting very fancy software, then you will be behind of the trend. But it is okay. No problem. I think I think not everyone have to follow the trend because sometimes the science is not always happening with high impact with the fancy one or trendy one. So traditional stuffs also very important without any fancy or let's say any fancy or trendy trendy techniques. So what am I doing? Okay, so I don't need to use this one. So let me see this one. So this is the expression. This is the expression. I want select the column of this column. Okay, so this is our data. So our data is in this way. And what am I doing? So let me drop na. Then your shape will be decreased. And let's see the cluster map. And standardization will be 1. So let me see what happened. I hope this works. So this use only one core and using this much memory. So I don't think it okay. So it produced. So last time it never show us the result. However, I don't think this is because this computer is better than before. I think this is because the WSL2 can manage this calculation. So I recommend you to update the Linux environment of the Linux environment of the window. So what can we learn from this clustering? So 7, 9, 8, 11 days are clustered here. And 10, 13, 12, 14, 15, 16 is clustered there. So I think I want to drop these 10 days because these 7, 8, 9, 10 should be clustered together, but 10 is a bit weird. Let me check the data. Okay, core method. So Spearman. Okay. And SV heat map. So these guys should be clustered together, but 10 day itself shows bit weird pattern. So I will drop this sample. Okay. Why are you using Spearman than Pearson? So maybe you have to ask yourself this stuff. Why are you using Spearman than Pearson? So let me remove the 10 day. Drop 10 day. Yeah. Drop 10 day. This one. There's no 10 day anymore, and I will overwrite this in the data. Okay. Good. Run and run. Now it is not so bad. It is not so bad. Okay. Then let me run it again. So without 10 day, we can cluster early stage and late stage more distinctly. So, what can we do anymore? What can we do anymore? So this left side is actually the clustering. So hierarchical clustering. So I want to select the genes first. I want, because there must be some genes that is not so distinct for the grouping. So I think I can group this and this. So maybe this is early, this is late. So late stage will show us different physiology. So let me remove the 12 day again. So 12 day is bit ambiguous, but I don't know. So is that good choice to remove the 12 day? Let me cluster this one. Cluster map. So cluster map shows, so 15 and 16 is associated, and 8 at night. But 7 and 11 is bit clustered but weird. No? And 12 and 13 and 40, 15 and 60, and 8 and 9. Okay, so let me use this 8, 9, and 12. Okay. Let's select it. Data equal data. So 8 day, 9 day, 12day, 13day, 14day, okay, 15day, 16day. Good, right? I think this is really good. So this is the way we when we use many data, you have to curate the data by your eyes, because you already know that some days should be clustered each other, but your data is sometimes contaminated, or your handling error result in different pattern of RNA-seq that is not desired. So from your visual inspection, you are actually removing the data. Let me see the clustering again here. Then maybe we observe different pattern of clustering. Why? What is the problem? What is the problem? Data and what? Drop no. And shape. And what? The condensed distance matrix must contain only finite. So this is happening because your data sometimes have very similar value, so you cannot calculate the distance between two, so it results in infinite value. So this is complaining about the only finite value should be existing in the distance matrix, but one of them is not that finite. Okay, so This is the problem. So how can we remove weird data? This is SciPy. So then maybe we can remove one more step for easy calculation. So let me remove 12 day. Let me remove 12 day. Then okay. Then hold on. I have to learn how to avoid this. Okay, so let's go together. So I think I already have some kind of So this is me. Some kind of I think I saw something weird. この野郎。この野郎。どういうサイトからダウンロードした？ Anyway. What am I doing here? Okay. And wiki. And maybe I have it here. Maybe I have it here. Okay. This one. This one is the one. So I will copy it and I will run it. Do I have SciPy? Yes, we have SciPy. And let me copy everything here. Data. Let's go with the data. Okay, this also complaining same thing. So. Let me check. No. Nothing. Ish. Okay, let me check this one also. Metric, method, word. So linkage array, word. So maybe word is the problem. So let's go to hierarchy. Let's go to hierarchy and see what kind of method it has. So there is word, and so I will use complete then. So let me use complete. So complete and 뭐 이씨 median then median median 되라 안 되네요. 잠시 다녀오겠습니다. Okay, I found the solution. So, usually the data looks like this. The infinite distance problem is always arised from the expression of zero. So none of them is expressing anything. Then 0, 0, 0, 0, 0. Then you cannot calculate between the gene which has 0, 0, 0, 0 and the other 0, 0, 0, 0. So we want to remove everything with only 0. So we can filter out the things that actually has some of the expression is should not be 0, right? So I made data filtered and with these two script. So maybe you can check the script what actually happening. So I can change this into 0 and can see the result. So which means that before I change this what why it happened. So standard scale 1 is working. So okay, so we have a problem with this matrix. So I want now. So this is also always this kind of challenge always happening. So let's. So what do we actually want to do is comparing the genes. So we want to change everything into Z-score. So we are actually changing the value using standard scale, but there's many functions already defined that change things into normalized value. So I think there was Z-score, right? So standard scalar. standard scalar. So how can we use it? So this is the standard scalar. So we can call this standard scalar. No. Okay, and we call this standard scalar. I think I have to fit it, right? The scalar fit the data, right? Okay. Fit transform, okay, data. Data filtered. Data filtered is now X. So let me check if it can be displayed. Please. Okay, anyway, it gives us some visualization, but so this is wrong, right? This is wrong. Maybe there is axis. True by default. Sure. Okay. So I think I have to just scale. So this is also scalar. X scale data filtered, but the way is axis 0. Installing fast cluster may give better performance. So okay, I will install it. So, 건다. Fast cluster. Fast cluster. Copy. And oh shit. Then axis 1. Axis 1 none. I'm installing best cluster. So when we talk something easily when we present, but the procedure always very painful. Because okay, now we have it. So I changed the scalar with this scale. So I will remove this one. And the result is coming like this. So we can see the pattern here. This one is clustered in this way, and this one is clustered this way. So we can assume that we can think that the 8 and 9 is here, and the other is here. So let's add the information there. So let me make the x in this way. No, in this way, and let's add index equal data filtered의 index and columns data filtered의 columns. 그죠? Good. And I will change it into X again and run it. So past cluster is installed, and I don't think it is improved the performance. Very good. So I will label this 8 and 9. So data frame. No, we have our X is like this. So 8 and 9 is 0. And the other is 1 and 1 and 1 and 1. This is y. And the x values. I think this should be transformed in this way. Shape. Cycle none, cluster, no, classification. 항상불, okay, port, random forester, classifier, RF. So nowadays, people loves a lot for making this classification. So okay, so I have to put T there. Transpose. What? X values. Okay. So it's done already. And feature importance. So we can see the feature importance and PLT hist. Okay, so there is strong feature importance. So this is too big. So still it has how many? 2,000. I think 2,000 is very enough. So let me. So 0.0005 and mask and x m and how many? 1,711 genes we can see. Okay, let me cluster it again. Clearer. And we can increase this one like this. And now you can see it is more clear than before. So I will use this one. Figure size 가로 5 세로 탭. Good. Seriously, this is so good. And I still want to use the standard scalar of Seaborn. This is too, I say, blurry. Then how can you do it? So this gene ID is the one that I want. So this is selected genes. Okay. And what do we have? Data filtered we have, right? Data filtered. So this is not corrected one, but still we can select it this way. So this is subset of the data. So I think we can cluster map standard the scale 0. Good, distinct. So this is why the reason why this happened. So compared to this one is that the way standardization method is different. So I used the Z-score method, but this must use different one. I don't know. We can check it. So C1 cluster map, and you can see the standardization standard scale is using what? So it use subtract the minimum and divide it by maximum. So this use the maximum value normalization. So there is the term like this. Maximum value normalization. So maximum value normalization. There is the term. So no, there's so many normalization method, but the maximum value min-max normalization is the one of the method. And JETSCO, there is JETSCO also, and Sabon, which means it may not have to this stops. Let me try. Data filtered and jet score 0. Ah, good. Ah, no. Why? I don't know. Anyway, so my jet score conversion was right. So now we have this. Let me change the size 5 to 10. So this is really good to see, and the gene is selected also, and we can, we can assign the class. We can assign the class. What do we have? So what we have done was that classification. So these genes are one class, the other genes are the other class. So we are labeling here. We labeled here, but we also want to label, so classify the genes. So how do you do it? So we can see that this is whether this is unregulated. Downregulated, unregulated, downregulated, unregulated. So this pattern and that pattern we can extract. How? Okay, data frame. So let's use this one. And data filtered, selected. I made new value and apply lambda x a 8-day and 9-day x 13-day 14-day and 15-day and 16-day. And how can we compare it? So maybe I can if So let me use this in this way. Let me use it in this way. So compare the mean value and axis. So this way, all right? This way. So this way means what? 오타가 남마는구만. mean. Then you can see the true or false. And I will label this one. So early to late. So from early to late, up regulated. Up regulated. Good. Up. Up regulated. Okay. So up regulated. So value count. Good. So now we have labels. So let me load Disney again. Let me load the Disney again. So what am I doing is I will use this Disney. But the problem is we have gene name in that way. So this is not gene actually. So this is transcript. So I think I have to change this into gene name. So just gene. Disney index for x in x split 0 okay, good. And I need to check if the genes are redundant or not. Value count. Is there anything other one? So non-zero count. True. So I think it is okay. So I want reset index and set index. 진 그쵸? and comma 1. good. cool. So now we have T-순위 value. No, I don't need T-순위 value. I think I don't need it. I need actual hour matrix. Where is the actual hour matrix? The actual matrix will be this one. Good, good, good. This one is hours. Feature to count. Okay, I will change this again. Unnamed. 0 apply. Apply. unnamed 땡땡의 제로 땡땡 띄우고 아니니? 아, yes. Good. Return to count. Corrected. So what I want to have is our selected genes. Why? What is the meaning? No. 왜 안 될까요? This should be done. I never see this kind of error. What is this error? 피곤합니다. Reindex. This means that maybe our index not having everything set. Let me minus selected genes. Okay, so there is no such genes. Only common value. Okay, good. So what have we done? Okay. Feature selected. Selected. 그쵸? and index. Let me use this one again. 따가워. So this is y again. Okay. So y, and let me use series function to change them into int. This is again y, and this is our data. Okay. Values will be x. Okay. So random forest again. Random forest classifier number of class estimator 2000개 fit x and y. Good. And which importance again hist. So let me see. So some of them is very important in this circumstance. Okay. So let me use this value 0.04 and data no. No. 그렇죠. So only one is selected. I want to increase. So these upstream blocks are important, very important for the classification of these genes. Let me see. Cluster map. 뿅. standard scale 0. Okay. So these genes having these kind of upstream sequences, and they are and how can I show it more informative way? Figure peak size 10 to 5, 10 to 10, 10 to 10, no, 20 to 10, 20 to 10. So it can show 30 to 10. Okay, it can show everything. So you don't need to cluster row. Row cluster first. Okay, put. So this is how we so I think so this one let me check this one again, and we can increase. So 26580 is decreased. 890 is decreased. So maybe these guys are decreased one, and the other is increased one. So then, okay, I will reindex. How can I reindex it? By use, and they. Unregulated. 아이씨 헷갈려. Selected. Unregulated. 아, 헷갈려. So we are having the upregulation tag here, right? So we have this one. So let me check. So we have this one, and we have what we have here is a pistol to count, and we also have the genes.